In this video, I want to have a look at integration with respect to time. So in our previous lessons, we've been having a look at if we have the displacement function for a particle, then we can find the velocity function. And if we have the velocity function, we can find the acceleration function. And we've been doing that through differentiation. But this time, we're going to have a look at working backwards from there. So if we have the acceleration, we can find the velocity. And if we have the velocity, we can find displacement. So to write that more formally, if we are given the velocity function v, we can integrate that function to find the displacement. If we're given the acceleration function, we can integrate that to find the velocity function. We need to always remember to add that constant of integration on the end. Now, if we're given more information, we can find the value of that constant of integration as well. So let's have a look at what that looks like with some examples. So our first example says the velocity of a particle is given by v equals 3t squared minus 8t plus 1. It also says that initially the particle is 2 centimeters to the left of the origin, and it asks us to find the displacement after 5 seconds. So to start with, we're going to integrate the velocity function to find the displacement function. We can use this extra piece of information to find the value of the constant, and then we can substitute in our 5 seconds to find the displacement after 5 seconds. So to do that, we're going to find the displacement function by integrating the velocity function. So integrating 3t squared minus 8t plus 1, and that's integrating with respect to t. So if we integrate that, we'd end up with t cubed minus 4t squared plus t plus c. Now we can use this extra bit. So initially, the particle is initially 2 meters to the left. Initially means when t is equal to 0. Now, if the particle is 2 centimeters to the left of the origin, we say that the displacement is minus 2. So if the particle is to the left, or if it's below the origin, then we're going to have a negative displacement. If it's above or it's to the right, then it's going to be positive. So the extra piece of information we're given is at t equals 0, x equals minus 2. So we can substitute those two pieces of information in here to find the value of c. So x is going to be minus 2, and then we're going to substitute 0 in, so we'd have 0 cubed minus 4 times 0 squared plus 0 plus c, which just means that c is equal to minus 2. So that means, therefore, the displacement function is going to be t cubed minus 4t squared plus t minus 2. So that's found our displacement function. The last thing asks us to find the displacement after 5 seconds. So we're going to say at t equals 5, and we'll substitute that in here. So we'll have x equals 5 cubed minus 4 times 5 squared plus 5 minus 2, and that'll work out to be 28 meters. Oh, centimeters, sorry, because it was centimeters up in the question as well. So at 5 seconds, our particle is 28 centimeters to the right of the origin. Our second question has us starting with acceleration instead. So it says the acceleration of a particle is given by a equals 18t minus 42. Initially, it is at the origin, moving with velocity of minus 30 meters per second. The question asks us to determine the displacement function and then find where the particle is at t equals 4. So the first thing we're going to do is, if we're given acceleration equals 18t minus 42, we're going to find the velocity function. So velocity is going to be the integral of 18t minus 42, and that's integrating with respect to t, integrating with respect to time. And that will give us 9t squared minus 42t plus c. So to figure out this constant, we're going to have to use this extra piece of information that's given to us. So initially, again, that means when t is equal to 0. Initially, the particle is at the origin, so that means the displacement is 0. And it's moving with velocity of minus 30 meters per second, so v equals minus 30. So at the moment, we've got velocity and we've got time, so we don't need this piece of information, but we will use that later. So we need at t equals 0, v equals minus 30. So we can have minus 30 equals 9 times 0 squared minus 42 times 0 plus c. So that means our c is equal to minus 30. So then we can rewrite our velocity function. So v equals 9t squared minus 42t minus 30. So now that we have our velocity function, we can find our displacement function. So x is going to be equal to the integral of 9t squared minus 42t minus 30. And we're integrating that with respect to t. So that's going to give us 3t cubed minus 21t squared minus 30t plus c. So now again, to find this new constant, we're going to use our x equals 0 when t equals 0. So we're going to have 0 equals 3 times 0 cubed minus 21 times 0 squared minus 30 times 0 plus c, which will just tell us that this time our constant is 0. So that means that our displacement function is just 3t cubed minus 21t squared minus 30t. So it doesn't have a constant on the end because our constant was just 0. So now that we have our displacement function, so we've done the first part of our question, it asks us to find the displacement at t equals 4. So at t equals 4, x is going to be equal to 3 times 4 cubed minus 21 times 4 squared minus 30 times 4. And that's going to give us minus 264 meters. So that's having a look at problems involving integrating with respect to time.